All right, so in this lesson, we are going to start looking at rational expressions. Okay, so rational expressions, the definition is basically just functions in the form of p of x over q and x, where p and q are polynomials with no common factors, and the degree of the denominator has to be at least 1. Okay, so essentially it's polynomials where you're dividing two different polynomials. So when we were in our polynomials unit and we talked about operations with polynomials, and we did division, I basically said just stick it in a fraction and we'll talk about how to deal with them later. Well, welcome to later. Okay, so we're learning how we can deal with these things. So it's basically two polynomials, and the rule is that the degree of the denominator has to be at least 1. Okay, so a degree of 1 means that you just have a linear term like x. So it's basically just saying you can't have your denominator just be a number, because if it is, it trivializes the whole thing. Okay, so that's all we're talking about here. Okay, so reducing or simplifying, all we're basically going to do is cancel any common factors. Okay, now personally, I find doing this very satisfying. I love simplifying rational expressions by multiplying, dividing, and just simplifying, because I just find them, very, very satisfying. So all that we're going to do is just cancel any common factors. Okay, so this guy right here, nothing too fancy. You've done problems like this before. You have an x to the 5th and an x to the 3rd. So 3 of these x's will cancel with 3 of these, which leaves me with 2 of them left, right? And the y's, these 2 y's will cancel with 2 of these, which leaves me with 6 of them left. 12 over 5 doesn't simplify, so I'm left with 12x squared in the top and 5y to the 6th in the bottom. So nothing too fancy or special there. All right, normally what you're going to have to do, though, is you're going to have to do some factoring. So I'm going to look at this guy. Two things that multiply to -6 and add to -5 would be -6 and +1. And in the denominator, I can start by factoring out a common factor of 2. So that's going to leave me with 2 times x squared minus 1. But then from there, x squared minus 1, that's a difference of 2 squares, right? So I can actually factor this one step farther. So it's going to be 2 times x plus 1 times x minus 1. Okay, and then these guys cancel because they're a common factor. So I'm left with x minus 6 on the top and 2 times x minus 1 on the bottom. You do not need to multiply that back out. It is perfectly fine if you leave it in factored form. If you want to multiply it out, that's fine. Personally, I don't put the time and effort into it. Okay, this guy right here. So we're going to factor the numerator. So 2 things that multiply to -3 and add to -2. So that's going to be x minus 3 times x plus 1. And then 2 things that multiply to 12 and add to -7 would be -3 and -4. These guys are a common factor, so those are going to cancel each other out. And I'm left with just x plus 1 over x minus 4. Okay, this guy, we got to factor this. So I am going to do some scratch work out to the side here. So multiply a and c, so -30. So I need 2 things that multiply to -30 and add up to 1. So +6 and -5. Right, GCF each half, so 2x times x plus 3, -5 times x plus 3. So that factors to 2x minus 5 times x plus 3. Okay, so 2x minus 5 times x plus 3. And then let's see the denominator. So multiply a and c, that's 20. So 2 things that add to 20. Multiply to 20 and add to -12. So let's see, that would be 2 and 10. So 4x squared minus 10x minus 2x plus 5. GCF over here would be 2x times 2x minus 5. GCF here would be 1. Oh, no, I'm sorry, -1 times 2x minus 5. So that's 2x minus 1 times 2x minus 5. Okay, and then I'm just checking for any common factors that I have, which in this case, I can factor the 2x, or cancel the 2x minus 5s. Okay, and I'm left with x plus 3 over 2x minus 1. And there we go. All right, and then this last guy, so factoring this one over here. So this top part, I'm going to see if I can factor this by grouping, right? So I'm going to split it, x cubed plus 2x squared minus 9x minus 18. So common factor of x squared. And over here, common factor of 9. So that's x squared minus 9 times x plus 2. So x squared minus 9 times x plus 2. And I'm just sort of eyeballing that and I'm saying, oh, wait, but this is going to factor more, right? That's a difference of 2 squares. So I'm going to be able to factor that again into x plus 3 times x minus 3. Okay, meanwhile, on the bottom, these guys, common factor of 5, right? So that's going to be the first thing I'm going to do is pull that common factor out. And then two things that multiply to negative 12 and add to negative 1 would be negative 4 and positive 3. Okay, and then from there, let's see, these guys cancel out. And that's it. So my final answer, I'm going to write, sorry, this should be x minus 3 times x plus 2 over 5 times x minus 4. And again, there's no need to multiply that out. You certainly can if you want to, but you do not have to. Okay, so that's all that there is when you are simplifying. It is pretty straightforward, and it's very connected to the idea of how simplifying fractions works, right? So when we talk about simplifying like 10 over 15, the reason that that works is that we say, well, that's 2 times 5, and that's 3 times 5, so you cancel a common factor of 5, and that's how you simplify your fractions, right? So that's the exact same thing that we're doing here. All right, so the next ones that we're going to look at is what happens when you are multiplying. Okay, and this is going to use a similar fraction rule. Remember how there's that rule with fractions that says if you're multiplying like 2/9 times 3/4, that when you have a common factor on the diagonals, you can cancel them out, right? 2 goes into both of these, goes in there once and there twice, and then you can multiply the resulting answers, right? Well, that's the same policy that we're going to use when we're multiplying our fractions. Okay, so we're going to factor everything, and then we'll just cross cancel any common factors that we have, just like you would in a regular fraction. Okay, now this guy doesn't really have any cross canceling to do. So what I'm going to start with first here, though, is I do have some negative exponents. So the very first thing that I'm going to do is I'm going to move this guy up to the top, and I'm going to move this guy down to the bottom so that I have everything kind of in place where it needs to be. All right, and let's see what we can cancel. 5 and 15, common factor of 5. 7 and 28, common factor of 7. All right, and now things are a little bit of a mess here, but I'm kind of looking at what I have. So I've got 4 A's in the bottom, and that'll cancel with these 3 A's and that 1 A, right? So these 3 A's and that 1 A will all cancel with that 8 to the 4th. I've got, let's see, 4 B's up here total, and those will cancel with these 4 B's here. Okay, and the thing you just have to be really careful of is that you don't miss anything. Like, this is a mess, right? There's a whole bunch of stuff crossed out everywhere. So you just really got to be careful that you don't miss anything when you go to pull it back together. Okay, so looking back at the top, the only thing that I have left is that 4. So I'm going to have just a 4 on the top. On the bottom, I've got a 3, 4 A's, and 6 B's. So 3, A to the 4th, B to the 6th. And there we go. That's the simplified form. Okay, this guy right here, this one we're going to have to start by factoring. So I'm noticing this guy has a GCF of 3x. So I'm going to start there. So it'll be 3x times 9x squared minus 1. Oh, and then I'm noticing that that's a difference of 2 squares. So I'm going to go ahead and finish factoring that. It'll be 3x plus 1 times 3x minus 1. Okay, this guy, I'm going to have to do some scratch work out. So multiply A and C, two things that multiply to -3 that add to +2, be -3 and positive, I'm sorry, add to -2, -3 and +1. Right, I'm going to GCF both sides. And then factor out that common factor. So that's 3x plus 1 times x minus 1. Okay. This guy over here, multiply A and C, two things that multiply to +3 and add to -4. Be -3 and -1. Let's see, GCF here would be 3x. I keep putting pluses where I mean to write minuses. So that factors to 3x minus 1 times x minus 1. Okay, so 3x minus 1 times x minus 1. And then that just doesn't factor, right? All right, so let me just copy all this stuff down. I needed 2 steps to factor one of these. All right, now let's see what we're going to have that will cancel. So here's a 3x plus 1 and a 3x plus 1. I've got let's see, an x minus 1 and another x minus 1. These 3's will cancel. And this 1x will cancel with one of those 2 x's. These guys, even though they're the same factor, since they're in the same level of the fraction, they don't cancel each other out. So this is going to simplify to 3x minus 1 squared over x. And that's it. All right, our next multiplication problem. So let's see, this is x minus 2. Ooh, this guy, that is a difference of 2, or a sum of 2 cubes, right? That's 3x cubed, and that's 2 cubed. So I can break this into cube root of the first thing, right? Matching sign, cube root of the second thing, cube root of the first thing squared, product of the 2. So opposite sign, product of the 2. And then plus the last thing squared, right? A little bit of a mess. That guy, not going to factor. How did I know that guy's not going to factor? Because it's right there. Okay, so use the structure of the problem sometimes to help you out. When you're looking at this, once you've factored this, the first thing I do whenever I do factoring a sum or a difference of 2 cubes is I check and see if this nonsense shows up anywhere else. Because if it does, I don't even think about how that would factor. Done. All right, but I do need to do something with this guy. So see how this guy's kind of backwards, right? Usually we have the x in the front. So what I'm going to do with this guy, this 2 minus x, is I'm going to do 2 things. First, I'm going to turn it around so it's negative x plus 2. And then I'm going to factor out the -1. Okay, because that gets this into a factor like all the other ones are, where it starts with a positive x. Okay, so I'm going to rewrite this 2 minus x as -1 times x minus 2. All right, and then let's see what cancels. These guys, as discussed, gone. These guys cancel each other out. I'm left with nothing in the top, but since I need this to remain a fraction, 1 is a placeholder. And on the bottom, I'm going to have a -1 times 3x plus 2. These are the ones where, when it's just like a whole number in the front, those are the ones where I tend to go ahead and multiply it out. If it's just like a coefficient, like this guy too, that sort of bugs me. Kind of want to write that as 5x minus 20. I would take it either way, but those are kind of the ones that catch my eye. All right, so that's multiplying. Last up, we have division. Okay, so when you divide 2 fractions, you flip the second one and then you multiply, right? So that's exactly what we're going to do here. We're going to factor everything and we're going to flip the second fraction. Okay, so this guy, right, starting by factoring. You notice how in this first top one, we've got that issue again where the x squared's in the back and usually we want it in the front. So I'm going to do two things kind of at the same time. I'm going to turn it around. So it's negative 2x squared plus 4x. And then when I factor out my GCF, I'm going to factor out a negative with it. So I'm going to factor out negative 2x. And then it becomes x minus 2. Okay, so negative 2x times x minus 2. All right, down here, two things that multiply to 6 and add to negative 5, negative 2, and negative 3. All right, and then here's the thing that's different with division. Change it to multiplication, and then we are flipping this fraction. So the 3x is going to be in the bottom, and when we factor this guy, we're going to write that in the top. So two things that multiply to 3 and add to negative 4, negative 3, negative 1. And then from there, it's exactly the same. Look for things that cancel. Those cancel. Those cancel. Those x's will cancel. So I'm left with negative 2 times x minus 1 over 3. Or negative 2x plus 2 over 3. Again, I'd take it either way. I just, I like these ones better if they're actually multiplied out. 'Tis a minor annoyance. All right, same deal with this guy. So 3, that doesn't factor. This guy I can pull out a 4. So that's pretty nice. Change to multiplication, and we're going to flip it. So this x squared plus 3x, I'm going to factor out an x and leave it with x plus 3, but it's on the bottom now. Two things that multiply to negative 6 and add to positive 1 would be positive 3 and negative 2. Okay, and then let's see. These guys cancel. These guys cancel. So I'm left with 3 over 4x. Okay, and then our last one here. So this last one, it looks like it's going to be long and complicated, but it's really not bad. It's just that you're doing it with another set of fractions. Okay, so I'm going to just kind of go in order. First one, just factoring it so I can pull out the 2. Since this one's being divided, it's going to get flipped. So 16x squared minus 1, that is a difference of 2 squares. So I can make that 4x plus 1 times 4x minus 1. X squared minus 9, that's also a difference of 2 squares. And then this guy, it's not being divided, so this is just going to stay put the way it is. Okay, cool. So these cancel. Those cancel. Let's see, this 5 I can cancel with the 10. That would be 2, right, left over. And I believe that's it. So in the top, I'm left with x times x minus 3. And in the bottom, 2 times 2 is 4. So 4 times 4x minus 1. Okay, and you could distribute that out if you wanted to, or just leave it that way. Either way is fine. Okay, so big things to watch out for. 1, division, make sure you flip it. Okay. 2, watch out for ones like this, where it's sort of backwards and you need to factor out a negative. Okay, that's a really important one, and that's one that people tend to mess up a lot. Okay, and then 3, just something to watch out for that I occasionally see. You can't simplify things until they're factored. Okay, so what I see sometimes is people will take a problem like this and they'll say, oh, the 6 and the 2 have a common factor, and they'll try to cancel that to 3 and 1. Okay, but you can't do that. That's not how fractions work, right? You have to have it in a product form before you can do any kind of canceling. All right, it's sort of like how, we talked about how, like, if you have 2 over 10, that you can simplify that because it's, right, 2 times 1, 2 times 5. That's where that comes from, right? Because it's multiplication. But think about if we tried to do that with addition. If I tried to take 2 over 10 and rewrite it as, actually, let me do a different example. Let's go with, just so I have some more options. So 4 over 9. If I tried to rewrite that as, say, 3 plus 1 over 3 plus 6, sorry, I sneezed, right? And you try to cancel it that way, 4/9 and 1/6 are not the same fraction, right? This is very small. That's almost a half. Okay, so they're very, very different things if you try to do it with this addition thing. It only works if it's multiplication. Okay, so just watch out for that. But the big one, again, the big one is watching out for those ones where you have to switch the sign like this guy.